Hey guys, this is your video for 6A-2 notes. These are all about triangle angles. So you might notice that on the 2 pages that you're going to need for today's notes, you see a lot of triangles, a lot of angles, things like that. So we're going to be taking notes over different types of angles, and then you will work on your independent practice for these. So let's start out with a paper that says triangle notes. Remember, after we finish these notes, you will be gluing these into your journal. So I'm going to zoom in here on the types of triangles. So it's important to talk about the different types of triangles that you may be seeing throughout the rest of this unit. And the first triangle I want to show you is a triangle with all sides equal to each other. Whenever you have a triangle with all sides equal, you indicate it using little tick marks along the lines. Each side gets 1 tick mark to show that they are the same size. Which, if the sides are the same, the angles will be the same. And whenever the angles are the same, they each get one little indication of one line saying that they're all the same size. Now let's talk about the name of this. This triangle is called an equilateral triangle. Equilateral triangle. And then if we come to a triangle, and let's pretend that Miss Garza is a perfect artist. She's not. I made this myself. So let's look at this triangle. Let's pretend that this side and this side are equal to each other. And whenever it's equal to each other, I indicate that using 2 different little slashes like that to say that these 2 sides are equal. And since the third side is not equal, I'm going to give it 2 slashes. These are different indications that you'll be using to kind of, see what triangles, helping to describe the triangle. I don't know why I could not figure out what to say just then. Okay, so there is a name for this type of triangle. Also, the angles, these 2 would be the same, and this one up here will be different. It'll be much smaller than the 2 at the bottom. So I'm going to give it 2 little kind of curvy things. I guess it's angle indication marks. This triangle is called an isosceles triangle. And I really hope I don't spell this wrong. So lease. It's E-C-E, sure. All right, now let's talk about if the triangle is all different side lengths. This is called a scalene triangle. A scalene triangle has all different side lengths. Let's say that that is different from that, which is different from that. Notice I gave all the different sides different amounts of tick marks to show that they're different sizes. So I'm going to do the same thing to the angles. I'm going to give that one 1, this one 2, and that one 3. And then the same thing for the last one, but the last triangle is very interesting. It's not named after the side lengths. It's actually named after a certain angle that we have inside of the triangle. Remember, if you ever make a perfect corner, like this one down here, it creates a perfect right angle. This is called a right angle. And we indicate right angles with boxes in the corner to show that they are perfect corners. So if there is a box in this corner right here, it is a 90-degree angle. This is called a right triangle. It's important to know right triangles because we will work with them a lot in the upcoming pathways. All right, so let's talk about right angles. If you ever have more than one angle adding up to 90 degrees, it would form a perfect corner like this. This is called complementary angles, which we have talked about already. Again, hopefully I'm spelling things right because I'm on the internet, but and then let's talk about this line. Anytime you have a straight up line just like that, it totals out to 180 degrees. And anytime you have multiple angles connected here, let's say that all these angles are of different sizes, but yet they all added up to 180, these angles are called supplementary. And something that is super interesting about triangles is that triangles, let me zoom out just a second. There is a line down here for a reason. We're going to write something. However, I have some triangles that I'm going to show you something with. Now, I can tell you that every angle inside, there's 3 angles inside of every single triangle. We know that. Every triangle you will ever have, the angles will add up to 180 degrees. And I'm going to prove it to you. So I got two different triangles here. They're different sizes. That means the angles are different sizes. The side lengths are maybe different from each other. And I'm going to show you that they will equal 180 degrees. Now, I know for a fact that the line like this equals 180 degrees, right? Because basically it would be two corners put together, and 90 plus 90 is 180. Side note, I meant to put 90 degrees for that angle right there. So, I'm going to take this. Again, you don't have the triangle. I do. And I'm going to rip this angle. I'm going to rip the top angle. And I'm going to rip the bottom angle. And you know what they create? All the angles put together create a perfect little 180 degree line. They fit perfectly on this line like that because a triangle's angles will add up to 180. Let's just try to make sure that this actually works and I'm not just lying to you. So I'm going to try a different size triangle. And I ripped out all the angles from this triangle. And all the angles put together create a 180 degree straight line. These angles are supplementary. So if you ever come across triangles that have a missing angle, like the ones at the bottom, you will be able to figure out what their missing side length is by trying to add all the angles up to 180. So if we have 30 and 60 and something we don't know, all three of these need to equal 180, so we're just going to do a little bit of math. So you could probably think of a different way to do this, an easier way, and there's a ton of ways to do these, so please go for it. I just wanted to write down the fact that 30 plus 60 plus we don't know. I could have put an X here, by the way, because it's an equation technically. Plus we don't know is going to equal 180. Now there's a couple of different ways you can do this. You can add up the 30 plus the 60 and get 90, and then you can know that 90 plus some random number is supposed to equal 180. And in order to figure out what this random number is, you will have to take 180 and subtract it by 90. 180 minus 90 is actually 90. And so that means that this missing piece was 90 degrees. And we know that 90 degrees are right triangles. So I'm just going to go ahead and mark my little indication with a right angle. Okay. So speaking of right triangles, in the second triangle here, I do see a right angle indication. And I only have one of them that is given to me. Technically two, because I already know that that's 90 degrees. So, of course, we have 90 degrees plus 45 degrees plus we don't know what this one is. They're all supposed to equal up to 180. If 90 and 45 put together make 100, is it 135? You know what, let's just go ahead and be a good model, Miss Garza, and I'm going to check just to make sure. 90 plus 45, yep, 135. So if 135 plus some random number is supposed to equal 180, I can take 180 and subtract 135. And I get 45. That means this missing angle right here was supposed to be 45 degrees. If you figure out a faster route to get to this answer, go for it. Okay? There's a lot of different ways to do this, but basically what you need to know is that all three of these are supposed to equal up to 180 degrees. Let's try one more example together. 130 plus 30 is 160. So I'm just going to go ahead and do that in the calculator. I'm going to say 180 minus 160 is 20. That means this little tiny acute angle over here was supposed to be 20 degrees. So there's that. Another way I could have done this was 180 minus 130 minus 30. It does equal to 20. Same thing. Okay. So let's move on to our next page. Oh yeah, actually before I do that, let's go ahead and make ourselves a little note. All triangle angles add up to 180 degrees, and actually it is very important. I'm going to go ahead and put this. All triangle interior angles add up to 180 degrees, and you're going to see why I said that in just a second. Interior, oh man, you can't see it. Sorry guys, okay, so now you can pause it in my video and see exactly what you're supposed to write down. All triangle angles add up to 180 degrees, and I snuck in that word interior because we have to be on the inside of the triangle in order to add in, or in order to add up to 80. The reason I say on the inside of the triangle is because when we get to our next page of notes, we're gonna have a triangle with with the line kind of continuing, because we now have angles on the exterior, which is the outside. So I'm going to go ahead and start off by saying the angles on the inside would be this one, oh, and this one. I marked all of them as different sizes because I have no clue what size these are. And I'm going to call this interior. All right, so while you see that, or as you see that, I have a triangle. It's supposed to be super, well, like I said, Ms. Garza is not the best drawer, so we're going to pretend that that triangle is a perfect match. Yep, darn, oh well. We're going to pretend that this triangle is a perfect match for the triangle that we have just witnessed in front of us. And so I'm going to take this triangle and I'm going to show you what I want to show you. There's this angle out here. I know that all the interior angles add up to 180. The exterior angle is this one here. I'm just going to go ahead and give it 4 of those angle symbols, just to say that I have no idea if it equals any of the ones inside, so we're just going to do it like that. This exterior angle is actually going to add up to all right, so sorry I had to write all that. This exterior angle is going to actually add up to these 2 angles here. The reason I know that is because, let's talk about this. Here's a straight line. This is a supplementary, this is 180 degrees. So that means that these 2 angles, whatever their measurements are, it is going to add up to 180 because they are supplementary. So if these angles add up to 180, and all 3 of these angles add up to 180, that must mean that if this plus this angle and this angle put together, it should all add up to 180 because that is right there, and it does. So we have 180 degrees because it was all triangles, so that's kind of interesting. The exterior angle will add up to the 2 sides over here. So I took off these 2 angles and I broke them off and put them there. So let's try an example triangle like this. An example triangle, I know that everything on the inside of a triangle equals up to 180. So I could go the long way if I were trying to find out what this exterior angle is. And I could add up these to try to make to 180 to figure that out, let's do it that way. Let's do it the long way on the first one, and on the second one we'll take the shortcut and use our noggin to figure it out. All right, so if 2 of these angles is 45 and 85, add them together to get 130. 130, so 180 minus 130 equals 50. So this angle here was supposed to equal 50 degrees. Just as a check, 50 plus 85 plus 45, they do add up to 180, so I was correct, okay? But I wasn't looking for that angle, I was looking for this one. So I know that these 2 are supposed to add up to 180, so I could do the same thing again. I could say 180 minus 50 and get 130. So the whole time, this right here was supposed to be 130 degrees. Now you might notice we got an answer of 130 at the beginning of this problem. It was here. It was whenever I added up the 2 interior angles that were opposite sides of the exterior angle. That was what I was trying to teach a second ago. So that's why it works. So since that was a way shorter, work, way shorter amount of work, I could have stopped right here and been done. So on this one, that's what I'm going to do. I'm going to take these two angles, here and here. Oh, just joking. Because that's the angle that I'm looking for. Oh well. So these two angles would have added up to 130. Well, that actually helps me a lot. Because if these two add up to 130, I need to take 130 and subtract it by 70 to find my missing number. So let's just do that real quick. So 130 minus 70 gives me 60. That means the missing angle is 60 degrees. All right, so you will come across some exterior angle questions, and now you have a lot of skills on your plate in order to understand how to do this. Okay, the next little section of angles we're going to talk about is vertical angles. You might remember that we talked about this before, but I just wanted to talk about it again. Vertical angles are angles that are on top of each other, and they are congruent always. So this part of the video notes is going to be pretty easy. I actually tried again to make perfect vertical angles exactly the same size. I'm going to use some scissors to cut them out just to kind of show you guys that that this is actually a thing, like it literally works. So I'm going to cut out the angles just like they were. Hopefully they cut. Okay. Oh, yep, that one fits there perfect. That one fits there perfect. And these fit here. Okay, see, I did good. So just to show you, these two angles are the exact same size because no matter which angle I put in on which side, they are the exact same size. However, I cannot fit this angle into this part because it does not match. It's not the same size. It's way too small. But this angle, I could put it here and here, and it would be the same exact size of an angle. So that tells me which ones are congruent. Vertical angles are congruent. They are the same size. So let's say that if this one is 80 degrees, I'll make it easy. Oh, just joking, I already did 80 over there. You know what, we don't even need to do the math. We're just gonna use our little indication marks to say which ones are equal. So now I didn't use any words to be like, yeah, these two angles are equal and these two angles are equal. I use little symbols to say that. So that's kind of why math is nice, because sometimes it takes shortcuts and uses symbols to tell you something. All right, so let's look at this set of vertical angles here. If I were trying to fill in the other blank angles with numbers, I'm going to use the numbers that they gave me to help me. So first of all, here we have vertical angles, which tells me that both of these are going to be 100. So I'm going to go ahead and use the angle indicator that it gave me and write 100 degrees. And then their next one is going to be 80. So right across from each other is 80 degrees, which totally makes sense because if they fall on the same line here, 180 equal 180. Same thing here, 180 equal 180. They fall along the same line, and it literally keeps going. Okay, so since we know the whole vertical line is complementary or a supplementary thing, it's probably going to help us on this question here. So all I know in this whole question is that 45 degrees is up here, which I can just go ahead and add in the 45 down here to know that. And then I'm missing the two larger angles. So if I know that at least two of those angles, this one and this one, are supposed to add up to 180, I could take 180, subtract by 45, and equal 130. And my new angle over here is 135. And that is your notes for triangle angles. There you go. Hope you liked my video. Don't forget to like, comment, and subscribe. Shout out to Ariana for making me end my videos with more dramaticness instead of just like a end cut. All right. See ya.